Now for solid cells for transmission measurements, the protocol, sample preparation protocol is a little bit more elaborate. So what we're gonna use is again a aluminum spacer, and this is the final product, which is ready to take into the glove box or even outside. So just to show the basic steps, the first one is simple, just practically tape this, saving a little bit of tape this over the back, again to avoid stickiness and a little messiness. Cut off the extra edges and then place it on this metal plate, and then with the regular tape we will remove this with two tabs, fix it to the plate, and the idea would be that the lower end is exactly where the upper end or the rim of the sample cell hole is, so we can very nicely load it and then remove any spilled sample and be able to put the other tape over it to completely seal it. Again here, highly recommended using the thinnest possible tape. If the sample, you have very limited sample and the sample has a lot of carbon, nitrogen, so it's very dilute, even recommended to use not the tape but the thinner 0.2 mil polypropylene window, and here it's actually quite possible to use it compared to the solution size. So once this is done, then what's required is here you need to mix, here in this case, the right amount, the optimal amount of sample and boron nitride. Generally these samples hold about 40 to 60 milligram of material, mainly boron nitride, and depending again on the complex, you need 5 to 10 milligrams of actual sample mixed in the 40 milligrams of boron nitride, and grind it together very thoroughly. Very important to be thorough because we're gonna do transmission, and obviously the concentration is going to affect the absorbance, and then gather all the materials together and then load it up. Carefully load it up, make sure it's nice and even. And here in this case I just simply don't have enough material, but obviously if this would be full then it's completely covered. I generally like to have a little bit more material, because then the next step is very carefully push it down, compact it, and then slowly lift it up. And then again with a pair of tweezers, remove this, just throw it away. Careful, this is the most exciting part. Remove the second tape, and now you should have two very nice clean metal surface, and then take another thin tape. Obviously transmission needs to be exactly the same, thin tape with tabs. Generally I put it on a cap so it's not going to shrivel up in the antechamber, and then take the tab and put it over. I stretch it a little bit, put it over, push it down, and so it's actually nice and safe and secure. So first I like to do is I don't put my finger on it, although especially in the glove box, if the gloves are clean, you can do that. I just sort of protect the window, so make sure I'm not gonna create a hole. This whole thing is going to be frozen in liquid nitrogen before being mounted to the sample rod. So if there is a hole on it, as it freezes, expands a little bit, and it's going to just break and spill the sample all over in the dewar. Let's scratch it a little bit. Okay, so now I have the 4 holes made, and so now I cut it around, and then at SSRL, when you check in for the beam line, make sure you're gonna ask solid cells, sample cell holders. And so this is done. This is now trash can go, and then practically the assembly will involve 2 gaskets, faceplate, and the back with screws. You will need a little hex key to attach it. It should go easy. I recommend to practice outside before you do anything inside. Once it's done, look at it, make sure that there are no cracks. If there are cracks, don't even try to collect data, just make it again. So that's it. Generally you have more than just 1 cells ready to go in case anything happens. Okay, and then same idea, assemble it, put it in a jar, take it out, put in liquid nitrogen, and mount it under liquid nitrogen.